Now to estimate the value of the slope and the intercept, we need these sums. So now we're going to use Excel functions to get the sums. Instead of we finding x times y and x squared and y squared ourselves, we can let Excel do that. But for that, let's first start by giving a name to these two variables. Okay, so highlight. So now we are only using the estimate, not the holdout sample. Okay, only the estimate. So these two columns. Okay, so we have the names at the top. So go to formula, create from selection, and top row. So now we have named these two columns, and that makes setting up these formulas a lot easier. So this is the sum of x. So we have sum of L1 crude. So that's our x. Okay. Now sum of y will be sum of unleaded is the name. Okay. Now the sum of x times y is given by sum product. The function that we use is sum product between x and y. So that will be L1 crude comma unleaded. So that will give us x times y for each pair, and then the sum of those products. Okay. Now x squared is given by sum SQ. So that will take each value, square it, and add them up. So this will be L1 crude, and we do the same thing, sum SQ for unleaded. Okay. So without we having to set up these columns, we can use the Excel functions in this fashion. Now sample size is count. Say let's use L1 crude. Okay. So sum of x, sum of y, sum of x times y, sum of x squared, sum of y squared, and we need the average. So the average is average of L1 crude, and then average of unleaded. Okay. So the numerator for computing B sub 1 is sum of xy minus sum of x times sum of y divided by the sample size. Denominator is sum of x squared minus sum of x squared over the sample size. Slope is take the numerator, divide by the denominator. Okay. Now intercept is y bar minus b sub 1 times x bar. Okay. And of course we could do this using the intercept function, y range first, so unleaded, and then L1 crude will give us the y-intercept, and then slope y range and x range gives us that. So our estimate for y, that is y hat, then is 0.687603 plus 0.027069x. Now let's look at the sums of squares. Okay, sums of squares will be here, y squared minus sum of y squared over sample size n. SSR is b sub 1 times the numerator for b sub 1, and SSE is the difference. Degrees of freedom is n minus 1 for total, 1 for SSR, and n minus 2 for SSE, and SS sum of squares divided by the degrees of freedom will give us the mean square. We don't have to compute that for the total. Okay, and then R squared is SSR divided by SST. We can also use an Excel function RSQ to find the R squared value, the coefficient of determination. It very much works like the intercept and slope functions. So RSQ is the name of the function, and then you give the Y range and the X range. So unleaded L1, okay, and there you go. So there are several ways of getting the same value. Okay, divide SSR by SST or use RSQ function. And S is square root of MSE. We'll talk more about this S little later. R squared is expressed as a percentage. Okay, so 94.3% of the variability in the gas prices is explained by the crude oil price, which makes sense. Now, of course, all of this can be generated using data analysis regression. Okay, the old information is still there, so let's clear that. Okay, now Y range is the unleaded column, so the Y range is the unleaded column, the X range is crude price column, label, okay, and the output range, let's put the output range right here. Okay, and click OK, and you get, and then you clean up the format. You see, this is what we have here also. Now, from the data analysis output, we have the estimate right here, and so remember SSR is that cell, regression SS is sum of squares. Now SSE is the residual. Remember, residual is another name for error, and SST is that cell. Now MSR and MSE are here. MSR is that one, and MSE is this. We'll look at F and significance of F in just a little bit. Okay. Now R squared is, okay, we calculated R squared here, and we can also use from the regression output. And the value of S from the regression output is right here. Okay. There is another way to find the value of S from Excel function, and that is STE YX, standard error of Y given X. and you do unleaded, the Y range first, and then the X range. This will give us the standard error as well. It's exactly the same thing. So there are several ways to get these results. Now let's find an interpretation for the coefficient determination. So this tells us that 94.3% of the variation in the unleaded gasoline prices per gallon is explained by the regression between unleaded price as the dependent variable Y and the crude oil price 1 month prior, lagged by a month, okay, as the independent variable. Okay, so that's the interpretation. Now from R squared we can find the correlation coefficient of the two variables X and Y. Now correlation, remember, can be positive or negative. So you have to first find the sign of the slope coefficient. If the slope is negative, correlation is negative. If the slope is positive, correlation is positive. And there is a function called sine which gives you -1 or +1, and we can take the b sub 1 value, so slope b sub 1, and find the sine that way, sine of b sub 1. Okay. So then correlation coefficient is the sine multiplied by square root of R squared. Okay, square root of R squared multiplied by the sine will give you the correlation coefficient between unleaded and crude oil price lagged by 1. And there is an Excel function to find the same thing, which is correl. Okay. And here for correlation, doesn't matter which order. You can go Y range and X range, or X range and Y range. Let's do Y range first and then the X range. So that will give you the correlation coefficient as well. Next we will look at testing for slope.